So let's begin. This is our session number 0, we will call it. I have started recording for all of you to know, and I will be sharing screen. I will make sure that you get the information, right information about LS-DYNA, explicit dynamic domain. I have listed these topics. We will make sure that we are sticking to those topics as well, so that we will finish in a timely manner, and if required we can extend it in a later part, maybe next week, next weekend, whenever you guys are ready. Okay, so I have these topics listed in front of me. Current and future market scenario for CI analyst. Okay, that is the first part. So before I go through the entire topic list. I want everyone to be alert, so just type in ready if you are ready for this fantastic session. Type in ready. RRR, if you can type in. I want your full engagement. Try and attend it you are using a laptop rather than just a mobile phone. Ready, everyone? Aniket says ready. Chandu says ready. Deepak says ready. Suvam says ready. Tejas says ready. Amazing. Yash says ready. Abhishek, good. Perfect. So almost all of you are ready now. Herbert says ready. Perfect. Okay. Satya says ready. Vedant says ready. Perfect, perfect, perfect. Okay, so it's good that you guys have a chat access. You have all these accesses. I will restore the video and audio access as well when we have a question answer session, because that's the most important part for all of us, that there will be a question answer session in a later part. All right, so let's begin, and let me take this opportunity to introduce myself. My name is Nachiket Phadke. I'm from Pune. It is in western part of Maharashtra, and also India. And I'm a career coach, a CI analyst, and I have two organizations which I run currently. One is Eleno Engineering Learning Center, where we teach people and train them and make them upgrade their knowledge to a next level in LS-DYNA. We have a commercial LS-DYNA license with Aru. So we have a good support, we have good engagement. I'm into LS-DYNA training since 2013. So this is my 10th year in training. But I'm using LS-DYNA since 2005. So this is almost my 18th year in LS-DYNA. And we cater right now to defense, railways, automotive domain, general engineering. Then we cater to um, various consumer good companies. And we also cater to some of the ME MTech or PhD pursuants for their research. Okay, we are into civil engineering domain as well, especially seismic analysis, vehicle crash or high speed impacts, or bullet penetrations, missile penetrations, all these kind of things we do. I will take you through the entirety of the applications of LS-DYNA, and then we will talk about various topics which are there. Okay, good. So this is what I do. This is what is my business is. And we have the second business. So the first is Eleno Engineering Learning Center. The second business is Eleno Energy LLP, where we do all types of services on a commercial manner. So I have a team of 25 engineers in Pune who are wholeheartedly working in CAE domain. We have a very small CAD department, two people, but those engineers are also well trained in CI activities. We make sure that we are providing all kinds of solutions to the organizations as well as individuals. And we typically work with wide variety of B2B or B2C related clients. As I said, civil engineers, mechanical engineers, electromechanical, electromagnetic engineering. So we try and work in a wide spread of varieties using explicit dynamic analysis. Okay, so let's begin. I'll share my screen first of all, and I'll try and give you an idea about what is it that Eleno does, what is it that we are capable of, or what we do, or what LS-DYNA can do. Okay, so let me just pull out one of the presentation which is related to, let's say, okay, so yes, there you go. I try to pull the master presentation. So we'll only invest 5 minutes to give you an idea how exactly LS-DYNA will be helpful. That's the only purpose here for this presentation sharing or screen sharing. So this is our master presentation. I'll just make sure that it is completely visible to you. Just type in visible if this is visible. V. Okay. What is it that we do? I just want to showcase the types of LS-DYNA possibilities. Visible? Type in V if this is visible. Okay, perfect. All right. So we will try and understand uh, various applications of CAE and LS-DYNA. So this is a seating system application, which is extremely exciting domain. We have almost 8 different organizations where we are vendors to for seating system domain. So this is a regulatory study which is mandatory for anyone who is manufacturing seats to be done. So there can be dynamic tests, there can be static, quasi-static tests. So some of the tests are listed here. There is a seat belt anchorage test. There is a frontal impact with dummy with seat belt, frontal impact with dummy without seat belt. So these kind of comparisons we typically do for various steering column manufacturers or steering system manufacturers, or the full scale integration to be done of a subsystem into a system level. That is something which we keep on carrying out. So this is an automotive domain which we take care of. Then we have various defense related activities which we do for or which can be done in LS-DYNA. So the biggest part, I just want to showcase how the simulations look like when there is a 20-kilometer crash, 20 km per hour crash for a non-occupant related kind of a domain. Okay, so bus domain is a very big domain for LS-DYNA. Then we have commercial vehicles for seat. Okay, so seating system of commercial vehicles, various defense equipments we try and do, various general engineering things we do. This is a elaborate defense presentation for explosion, blast. This is our regular activity. So whatever images you see right now or whatever simulations you see right now, they are 100% copyright free. What do I mean by that? These are not the data points from customer side. So they are freely available models on LS-DYNA website, or they are free CAD models from GrabCAD, so that there is no copyright infringement even if I upload this particular video on YouTube. So these are some of the open source models, you can call it. So this is a full vehicle mine blast without an underbelly hull. What happens to the dummy? What is thorax criteria, thorax injury? How is exactly the head acceleration, the chest acceleration? All these things we try and measure using the explicit dynamic simulation domain. So we have this is an under vehicle blast, but this is having, as you can see, this is having a hull. Okay, it's an additional hull. We were trying to propose it to Ordnance Factory. Now they have split into 7 different factories. So this is something which is an explicit dynamic or time domain. Okay, now you can actually see the timestamp here. If you can observe closely, this is a time in seconds. So it is 0.001 or maybe maximum 2. So 0.002 is 2 milliseconds. So we are having a 5 kilogram explosive which is getting blasted off, and 5 kilogram TNT is a huge amount of TNT for a small vehicle like this. And it is releasing all of its energy in 2 milliseconds. Okay, so this is how it is. It may look like it is running for 4-5 seconds, but it is due to the frame rate which I have dropped. So this is something which is extremely important for an analyst or a CAE analyst to be to make sure that you are suggesting a good output to the customer. Okay, or any kind of a simulation solution you want to purpose there. So this is a again, this is a supersonic penetrator in the bunker. The bunker width is 2 meter. Okay, it's a defense bunker, and it is supposed to penetrate and go inside the bunker and then blast. Okay, so it's like a spice bomb. And we did work closely with all the defense industry or defense research establishments to make sure that we are very close to the actual results. The trials are still going on. But as I said, this is a representative image, nothing to be worried about if you want to showcase this to anyone. Okay, then we have various material characterization which can be done using LS-DYNA. So there will be full vehicle simulation, full vehicle crash simulation, and the material changes its original properties or it behaves differently when it is loaded in a different strain rate environment. So the strain rate effect is supposed to be calculated, and we do a split Hopkinson pressure bar test. It is called SHPB, split Hopkinson pressure bar. So it's a standard procedure to evaluate what is the strain rate, at what strain rate, how the material is going to behave. And accordingly, LS Dyna chooses the strain rate based on the amount of loading or the rate of loading as it changes. Okay, so that's what we do. This is an interesting case where we have soil model using SPH particles. So it is called as spherical particle hydrodynamic. It's a procedure in LS Dyna to model a meshless part. Okay, and the soil is modeled, and these hammers rotate and they clear the mines. Okay, so what they do, their main purpose is to keep on rotating in front of, let's say, an army battle tank. And whenever there is a hammer which is actually getting impacted onto the mine is going to get blasted off. That blast will be contained just behind this particular thick steel sheet, and there will be a clear path for other vehicles to follow because there will be no mines for sure. So these hammers are typically 30 kilogram each, and they are rotating at 300 rpm, and they are moving in a linear velocity of 4 kilometers per hour. So you have a complex scenario where there is a linear movement, there is a rotary movement, there is a soil, and there is going to be some kind of an obstruction as well. So two hammers at a time, they are going to touch, and you will have different forces on the shaft, and there has to be a correct bearing selection to be done, because ultimately the entire load is going to get passed on to the bearing. So this is an example of what can be done using LS Dyna in an explicit dynamic domain. Guys, are you finding this interesting? Are you able to follow me, or am I going too fast? Just let me know if I'm going too fast. I'll just slow myself down. Interesting, right? You're able to follow me, correct? Wow, there are more people joined in. Welcome all those who joined little late. I did not got chance to welcome you all. So thanks for being here on invitation. Okay, so I'll share. Good, it's fine, correct? Perfect. Okay, so let me share screen again. And I'm purposefully sharing my entire screen so that you guys get a clear idea what I'm doing. This is called as an electromagnetic rail gun, which is kind of a weapon which accelerates a particular object uh, to 7 times the speed of sound, 8 times the speed of sound without explosives. So it uses electric current. It works on various principles of electromagnetics, and all these things can be simulated using LS Dyna. So we are actually supplying a 10 megajoule current in less than 7 milliseconds. Okay, so we are doing a fast discharge between these two rails, and the projectile or the part which is there in between these two rails tightly fit is going to get accelerated due to a fast discharge of the current. It is called as Lorentz force. Okay, so there is a principle behind that, and we can simulate this using explicit dynamic analysis in LS Dyna. Okay, so composites are extremely important for any organization, especially military or especially defense, because composites don't rust. They have a dimensional stability. They really don't have too much with regards to reaction to the environment, and not just rusting. It can be any other environment. It can be electromagnetic shielding. So composites are well suited for defense industry. They are not for mass production, but they are for batch production. So we converted this multi-barrel rocket launcher steel tubes and tried to analyze what happens if we convert those steel tubes into a composite tube. Okay, and that's what is called as Pinaka, and that is what we do. This is a bird strike. Of course, again, as I said, all these images are copyright free. We purposefully converted them in a different format. So you may see them very rudimentary. You may see them that they are very academic, but actually we worked on a very detailed model, but this is like just a showcase. So you can actually see the bird is also modeled using SPH material, and we tried to simulate what happens if a bird strikes on a wing, what happens if it goes inside the engine. There will be a blade contamination analysis, which every single rotary engine manufacturer follows using LS-DYNA. Okay, so there are wide applications of LS-DYNA in aero industry as well, especially with bird strikes and blade contamination. These two studies are very much done in LS-DYNA across the industry. We have all types of stackers. We have dock levelers. So this is more of a material handling side. And this is what LS-DYNA can do. Now, there are few more things which LS-DYNA can do. I'll just try and get one of the presentation if it is available, which is related to, I think it is related to defense, but I want to show you some security barriers, what can be done with security barriers. Yeah, so this is one of the example of V-shape hull blast. It's kind of a real time. And what happens with a 10 kilogram blast? That's something which we can study there. I'll show you some of the anime. This you already saw. Yeah, this is something which is with regards to, it is called as a mine protected vehicle. It has a pure V-shape hull. Right now, what you see is a dummy or toy tank. As I said, I don't want to infringe any copyright. So these are not going to be the flat underbelly. It is going to be a V-shape underbelly. And what happens to the occupant? How is the injury? What is the G value in head, thorax or chest, we call it, or hip, that is H point. All these injury criteria we try and understand. Okay, so you can actually see this. This is a toy vehicle which we downloaded from GrabCAD for showcase purpose. And what happens to the tank? How exactly it is going to get lift up? Yeah, this is a vehicle security barrier, a very interesting example, and this market is slowly but steadily picking up. There are manufacturers of security barriers as per PAS 68, ASTM standards or IWA standard. And this vehicle actually hits at 80 kilometers per hour on a gate, and it is having a mass of 8 tons. So it's a huge kinetic energy. And this kinetic energy needs to be getting converted into a permanent deformation of a gate. So the main aim is not to survive or not to keep an occupant alive. The main aim is to not allow any vehicle to pass through this particular gate point. So it can be used for thermonuclear power plants or high security areas, embassies. So whatever embassies you go in your maybe state capital or national capital, and if you see a large sliding gate, it has a width of 4 meter, opening of a 4 meter, which is standard. And if you can see that gate, it is supposed to be a crash rated gate. Okay, so it is rated, it is tested. It's not just piece of steel which is just sliding around. Okay, so there will be a lot of things which will be inside. So this is one of the assault trackway example. Again, it uses LS-DYNA for soil modeling. So whatever you see, the light blue part, it is all SPH, it is all soil. And because of this soil characteristic, you can actually see there are ruts getting formed once the vehicle moves on a loose soil. Okay, so this is a army related project, but this is our own project. So the design is our own. The manufacturing is from Eleanor's side, and that's why you can actually see the real time movement of a truck. The wheel rotates, it moves at 40 kilometers per hour, and it creates a rut. Okay, you can actually see the ruts getting created, and we have to do some 10,000 passes. So this is how for real time product development LS-DYNA will be useful. So the prototype cost will be in 20-30 lakh rupees. Maybe 20 lakh is 2 million rupees. Okay, so that's something which is too much of a cost for a physical prototype. The CAE test will not cost, it will be a fraction of that cost. You may understand that. Okay, so this is something which can be done using LS-DYNA. Helipad landing we do, composites we do. So you can see a ceramic composite. This you already saw. And this is all what you actually saw earlier. Yeah. Okay. So this is a tractor seat for some kind of a misuse loading. So if you want to pull down or get up onto the tractor, but you don't have any handle, you are going to grab the seat and you are going to get onto the top of it. So it's a misuse test. There is no regulation as such. And these are the simulations or animations what you saw are with real-time material data which is being fed. So we are going to talk about it in a detailed manner. We'll make sure that we are going through for next 30 minutes with the point by point description which I created earlier. And then we will make sure that your questions will be also answered. Interesting? Okay, Kunal says make it slow. So Kunal, if you have any questions, just make sure that you write down that question. And in the last question answer sessions between 6:45 to 7 o'clock, I will make sure I answer all the questions. Okay. So sorry for that because I want to cover most of the part. That's why I'm getting little faster. But you will have this recording with you in a later part. If you attend till last, it's all going to be good. Type in interesting if this was interesting part to be discussed. Okay, so it is an explicit dynamic simulation domain, and these are various applications. So automotive, railways, defense, then you have general engineering. All these things we actually made sure that I tried to cover it. These are some of the showcases, and it's a huge career. Okay, it's a lot. You can actually imagine. I'm working in LS Dyna since 18 years. LS Dyna is there in market since 1980s. And to be very frank, it is 1983. So it is like 40 years now. It is in market. So it's a proven technology. It's not something which is going to go away with a wind blow. It's going to stay. It is very proven. It is used by all automotive industries, all defense industries. So it's a good career opportunity. Okay, so that is something which you should be linking to. So how many of you, just a simple poll, how many of you are still studying either master's degree or bachelor's degree in engineering? Type in studying. Yes, if you are still studying. Tejas has raised hand. How many of you are still studying? Studying. Abhishek is still studying. Good. That's nice. Who else? Tejas said he's studying. All others, are you searching for jobs or are you doing job or where are you? What is your status? You can just type in if you are doing a job, just type in job. If you are searching for job, uh, you can call yourself as a fresher. Aniket is doing a job, studying BTech. Okay, Vedant is studying, Tejas is studying, Shreya is doing job, Anirban is doing job, Krunal is doing job. Amazing, amazing. Okay, nice. So there is a majority of people who are actually right now working. Okay, what is difference between ANSYS LS? No, there is no difference. ANSYS has Sai, ANSYS has bought LS Dyna. So ANSYS LS Dyna and LS Dyna is same. No difference. Internship in CAE, Swapnil is doing amazing, good, nice. Searching for job, amazing, Tushar. Uh, okay, good. Chetan is studying in BE Mechanical. Amazing. Thanks, guys. Thanks for the replies. I can now understand you better. So let's chalk down what are the things which we are going to talk about. Okay. So content of class, it starts with I'm just copying this content and going to post it in one of the blank presentation so that everyone understands. So let me just close these presentations first of all. File new, and I'll just go for a blank. Oops. There you go. So I'll call it at session 0. Oh, okay. I'm not sharing my screen. 1 second. Let me just share my screen again. Perfect. Visible, guys, in new screen. So we are having LS Dyna session 0 here. And I'll just paste what is it that we are going to cover today. Yep. Yes. So the first part is current and future market scenario for CAE analyst. Okay, of course, we are going to discuss that. And we will also have discussion about what is LNO, what we do. We have already done that. What is crashworthiness analysis domain? Okay, it's a very important question which I typically get asked by many people. And that's something which I want to throw light on. What is CAE and steps in CAE? What is static and dynamic load case scenario? What is explicit dynamic analysis domain? So these two questions I will try and answer in one single slide so that you will have a better clarity about it. Why LS-DYNA is widely popular. Okay, so that's an important understanding to be done. Why you are supposed to choose LS-DYNA as your solver for explicit dynamic analysis. But first of all, we have to understand what is explicit dynamic, what is static and dynamic scenario. Then we will try and go forward with what are the LS-DYNA applications in various domains, which I tried to make it early because I just wanted to trigger an interest in you. Okay, so now you know what are the applications. You can actually listen to what is explicit dynamic more carefully. Okay, so we have already covered this. What are the career perspective? How is going to be your career path? How companies choose the engineers? What is exactly the starting point of your career when you choose LS-DYNA as your domain? How LNO can help you in entire activity and open question answer sessions. Okay, so it's very fairly simple activity which we are going to do anyway. And we will just try, and I'm just trying to get rid of this. I don't know. Maybe what I will do, I'll just create a blank presentation. Okay, so this is, yeah, this is better. Yep. Now you can see my screen in a better manner. 1 second. Just close this. And I'll share my window. Yes. All right. So I'll use my regular pen and I'll try and get the information for you. What is the current and future market scenario for CA analyst? The first important part is we should understand a design process. So get your pen and paper ready. Type in PP if you are ready with pen and paper. Okay. Type in PP if you are ready with pen and paper. I want you to take a lot of notes because this is going to be a hell lot of information. I don't want you to lose any of the part. Okay, so that's why I'm asking you to be ready with pen and paper. Get ready with pen and paper. Thanks, thanks, thanks. Thanks, Shreya. Thanks, Herbert. Thanks, Shravan. Okay, so the first important part is the design process itself. Okay, so you should be knowing what is the design process in any organization. I have put a PowerPoint presentation over LinkedIn maybe 3 or 4 days back. If you are not following me on LinkedIn, you can follow me there. Uh, Basically, this entire design process needs to be understood. And for that, design, simulation, test, prototypes, all these things should be there. So it starts with concept. I'll just break it down to 5 different stages. The first stage is a concept stage for anyone. Okay, so it will have a concept understanding, and the concept comes from market, or concept always comes from the sales engineers, those who are on field, those who are actually talking to the real time customers. They give you the concept. Okay, and this concept needs to be converted to industrial design and engineering design. Okay, so the industrial design is more towards how it looks, how it feels, what are the colors, how the market demand is, what are the features to be put in. these things, if you take into account an automobile, let's take an account of new Tata Nexon, for example. So if you have an upgrade to be done, there will be a lot of concept which is going to go to the industrial designers and lot of concept which goes to the engineering team. So engineering is someone who is going to manufacture it. Okay, and for manufacturing, they need to have the correct material, whether it is manufacturable, you have put a curve, but am I able to manufacture it? Is it going to be flawless? Am I going to fit it? Whether this material is durable, whether it can sustain a UV light, whether it can sustain crash, whether it can sustain a door sack, whether the static load is good enough, whether the cost is in market or in a particular bracket or not. All these things are to be decided by engineering team. And whatever you are going to talk about the outermost part or body shell or the design lines or the design language, it's all going to come under industrial design. So let's start with this. So you have engineering department. It will start with CAD, that is computer aided design, 3D parts. They will try and merge all the parts. They will try and do the assemblies. They will try and design everything. And while this is going on, there will be a team which is going to work, which is computer aided engineering team for various things. So the CAE department, I'll just have a short off-topic discussion here. It is actually on topic, but for this entire design phase, it is off topic. So CAE will be having too many things which can be done. There will be finite element methods. Again, in FEM, there will be many things which needs to be done. There will be crash, there will be static analysis, there will be fatigue NVH, or fatigue durability and NVH. Okay, then there will be CFD. So you'll have flow analysis, you will have coefficient of drag, you will have heat transfer. So heat, that is thermal analysis. So in CAE, there will be, it's a big umbrella of numerical calculations, but it will consist of finite element methods. It will consist of finite difference methods. It will consist of thermal analysis. It will consist of electromagnetics. It will consist of SPH. It will consist of discrete element methods. So there can be numerous methods under CAE. But what is happening, typically CAE and FEA are being used in an interchangeable manner because the dominant part is finite element analysis. You can actually see in FEM, you can do crash. Using FEM, you can do static analysis. Using FEM, you can do fatigue. Using FEM, you can do NVH. So these things can be done using a finite element method. And that's why CAE and FEM are typically being used in an interchangeable manner. Can you write this down? Type in done if you are done writing. You can take this down. Okay, so the types of FEA. Now you are not supposed to select a finite element analysis tool first. What is the main thing which in the career guidance, what I want to talk about is somebody, maybe your professors have suggested, or maybe your senior has selected one of the domain or one of the tool. That doesn't mean you are supposed to select the same domain or same tool. You are supposed to first of all understand the product domain. Okay, first of all, understand the design cycle. Where do you fit? You fit in a design department and you are an integral part of a design department. And you are going to talk to two different departments inside the design. One is CAD designers, that is 3D modelers. The other is going to be prototype department. So you are sitting in between them. You are doing virtual prototyping and you are going to talk to both of them. What is it that I'm doing? Is it making sense to you? And do you want my help or not? So you are an essential part of a design department. You are not a standalone department. Okay, that's a clarity which I wanted to give you. Then you are there is electromagnetism, EM. After thermal, it is EM, electromagnetics. So it can be EMI, EMC. It can be the railgun which I talked about. Motors are being designed using the entire CAE process nowadays. So this is something which is a part of CAE. Now coming back to this particular diagram, you have concept, you have industrial designers, you have engineer designers, you have CAD, CAE, and proto departments. And then there is release. Okay, then your product. So there will be a loop here. The loop will be very simple. The loop is like this. I'll go micro now. You have CAE department in between. You have CAD department here, and you have, or I'll call it as a design department. Okay, instead of CAD. So you have a design department, you have CAE, and you have actual prototype or proto department. So they will also have a lot of insights because they are going to witness the physical test. And we are not here to replace physical tests. So what is the use of CAE? Use of CAE is to reduce. Nobody is going to tell you this. Okay, so take this down. To reduce number of prototypes. Okay, and when I say prototype, I really mean that it is supposed to be a physical prototype. Okay, when we say it as a virtual prototype, it is going to be a CAE model. Whatever you saw in the earlier presentation is all virtual prototyping. There was real material, there was real connection, bolts were there, welding was there, contacts were there, parts were getting meshed up. All these things come under virtual prototyping technique. And when it comes to the physical prototyping, it's going to be costly and time consuming. All right. So you may have seen a lot of cars running on roads which are camouflaged. So they are having some black and white stripes or black and white stickers. These are called as physical prototypes. So they are one to one and they work. Okay. So the definition of prototype is very simple. It is supposed to be 1:1 and working. Something which is 1:1 and working, you will call it as a prototype. But if you scale it down, then you call it as a model. You are not going to call it as a prototype. So scaling is possible, but if you scale it down or scale it up, it is all going to be a model. It is not going to be a prototype. Making sense? Type in makes sense if this is making sense. SPH is sphered particle hydrodynamic. Can I type in here? Sphere or spherical particle hydrodynamic model. Is this making sense, guys? So why we are using CAE? We are using CAE not to replace physical prototype, but to reduce number of physical prototypes. What are the advantages? The first advantage is once you reduce number of physical prototypes, your time to market increases or time to market reduces. That means you're faster to the market because you don't have to build a lot of physical prototypes. The second is your cost comes down. The product development cost comes down and your product can be competitive. The price will be competitive and your product becomes aspirational. People will aspire to buy your product because it is jam-packed with the features. You are very fast to the market. You are listening to customers. So the customers will want to wait for your product to come into the market. Okay, and that is something which is extremely important for a dynamic market condition. Okay, so everyone done writing what is the design process, what is use of CAE. So we tried to discuss 2-3 important aspects here. What is the design process? That's what we tried to discuss. You can draw this diagram. I will wait for 30 seconds if you want some time. We discussed about what is it that is included in CAE. We discussed about use of CAE. It is to reduce number of prototypes and where CAE sits. So typical ratio is if you have 5 design engineers, 1 prototype engineer and 1 CAE guy. Of course, prototype engineer, it can increase if your product is larger because it may go to 1 to 3 maybe. So for behind 5 design engineers, there will be 1 CAE guy and 1 to 3 prototype guys, which are extremely well versed with how to actually manufacture a part without having mass production tools. So prototype is not being, it is called as cut and weld process. So you create a part using a cut some part, weld some part, make it grind. It should look like a final finished part. So it's a different kind of a skill. CAE is a different kind of a skill where you want to talk to a designer continuously in a loop. That okay, this if the design fails, you have to talk to them and you have to improve the design. Again, you have to do CAE and this goes on. Then the prototype guys comes in when you have a ready virtual prototype, which is actually satisfying the requirements. So prototype guy can throw an insight to a CAE guy and a CAD guy that I think what you have done is correct, but I think this weld, when it goes to the physical prototype, it's not possible. It's not possible to weld it like this. So you'll have to change the weld. So CAE guy is again going to do one more calculation, one more iteration, and then there will be an exchange of ideas, and then only the final prototype kickoff is going to happen. Okay, so it's a very complex process in any product manufacturing. We are not developing a software, we are developing something which is physical, which is going to be in a mass production. It can be a car, it can be a toy, it can be a white good like a refrigerator or an air conditioner or a washing machine. It can be a general equipment, it can be a defense equipment, it can be railways, it can be seats inside the car. So it can be a varied kind of a spectrum which is going to be there. Clear? Type in clear if this fundamentals are clear to you. If you have questions, you can ask me in the comment box. Okay, so I can try and answer if there are any questions. Type in clear if it is clear. Okay, Suvam says clear, Chandu says clear, Tejas says clear, Herbert says clear, Aniket says clear, amazing. Okay, Jignesh says clear, Abhishek says clear. Okay, good. Nice. So we have two Abhisheks here. Kudal says clear, Vedant says clear, amazing, amazing. Thanks a lot, guys. Thanks for feedback. This is the only way I can actually understand whether you are receiving the correct information or not. Okay, so we tried to go through the what is exactly what is CAE and steps in CAE we will try and cover. We covered what is CAE. It is a virtual prototyping technique. That is what we cleared. What are the steps in CAE? We'll try to see here itself. There are only 3 steps in CAE. It's very simple. The first step is called as pre-processing. Okay. Second step is called as solving. And then you have post-processing. So you have pre-processing, solving, and post-processing to be done as an integral part of the entire ecosystem. So there are questions. Sir, if I learn only the hypermesh, can I get entry into CAE jobs? You may get an entry. You may get a job to be done for just doing the meshing, converting some CAD parts into a mesh part. But that's not CAE. What you need to understand here is there will be a pre-processing, there will be solving, there will be post-processing. Then you are supposed to recommend, you are supposed to understand the product, you are supposed to recommend to the end user. For you, the end user is a CAD guy or a prototype guy, and you are supposed to evolve yourself into the product. So it can be seating system, it can be full vehicle, it can be interior system, door panels, instrument panel, floor console. It can be the defense equipments like the full hull, etc., etc. So when we talk about CAE, we are never supposed to talk about just the pre-processing, just the solver. Only solver is also useless. Only pre-processing is also useless. Only having a knowledge of just creating a PowerPoint presentation is also of no use. Making sense? So it is extremely important for fresh engineers or those who want to switch from uh, CAD job to CAE job. You are supposed to learn the entire CAE process. You need a mentor. You need someone who knows CAE in a very well versed manner. You know, someone who actually not just is aware about pre-processing. It may not be a good entry point because you will be feeling stuck at the same point. There are many students coming to me asking for help to get jobs because they are doing meshing for 3 long years, 2 long years, and they really don't have any exposure to a solver. So they learn solver from me, then they upgrade themselves, and then they get placed in the either the same organization in a different department or in a different organization based on their CAE skills, not just their meshing skills. So there are institutes who just fake around that, okay, you learn hypermesh or you learn ANSA and you will get a job. There are many people who learned ANSA, but they are jobless still Why? Because they are not understanding the entirety of a CAE process. Okay. Why I try to boil it down like this. For 5 design engineers, you have just one opening of CAE guy or CAE engineer. Getting my point? So the jobs are going to be hard to find, but how is going to be your journey once you get a job? For first 2 years, let's say this is your salary. For first, this is 1 year, 2 year, 3, 4, 5, 6, 7. Okay. We'll just talk about 7 years. So for first year, the salary will be like this. There will be 10% increment. There will be another 10% increment. And we will have a parallel graph of knowledge. So if I just try and change the color, uh, we will have a parallel graph of knowledge here. Okay. So you will have this number of years. The knowledge graph is red. So you have this salary graph, you have knowledge graph. So knowledge graph, you will be learning super fast. Okay, in first 2 years, because everything is new to you. So you are acquiring skill with regards to software. You are acquiring skills with regards to interpersonal relations. You are acquiring skills with regards to the product. Okay, so there will be many skills, many knowledge based points which you are going to acquire in first 1 or 2 years, 1, 2, 3 years. Then it's going to ramp up like this, but your salary is going to ramp up like this. So I will just change it again back to the black one. So your salary part, is this making sense, guys? Because you may be doing a switch here. Okay, you may be doing a switch here. Okay, and you are going to have a salary hold, but in core mechanical engineering domain, you expecting a huge salary at the beginning is not going to happen. Okay. So when I say the current salary brackets, if I just openly discuss, it starts at 3.6 lakhs per annum. Okay. That's a base salary for a GET who knows Hypermesh, LS-DYNA or Abacus or something like that. So I will call them as a fresher plus candidate in open market. Okay. Fresher plus. So what is fresher plus? They don't have a real time experience, but they have a good handholding done. Let's say at LNO or at any other institute where there is a good kind of a teaching environment. So you have a good salary to start with. 3.6, it may go to 6.6 also. We have seen that. But the minimum salary I'm talking about is 6.6, 3.6. So you'll have 3.6, then there will be 20% rise. Then there will be another 20% rise. You will have a good amount of knowledge here at this point. After 2 years, you will think about switching. Nothing bad in switching. And once you think about switching, you will have a first jump, you will have a second jump, you will have a third jump. And that way, your knowledge which you have gained in this period is going to help you out. So this is not a typical IT like cycle. There are misconceptions about how mechanical industry works and how IT industry works. Don't compare yourself with somebody who is having no overheads, no factory, no manufacturing, no material procurement, no workers, no unions, okay, no supply chain. You are using your computers, you are having an office, you are launching a product that has very less of an overhead. Paying a light bill is a joke for a manufacturing factory. The total light bill what an IT industry can generate in an year can be a 1 month light bill for one factory of a one organization. Is this making sense? So don't try and compare yourself in the same category of IT engineers. They are going to earn because they have lower overheads, but they have cycles. They have their own cycles. Grass is always greener on other side. So don't lose hopes when you are coming to a core engineering domain, because this is a product domain. Products are not going to go anywhere. Products are here to stay. And when there are products, there are going to be supply chains. When there are supply chains, there will be factories, there will be ancillaries, there will be vendors, there will be unions, there will be workers. Clear? Am I tried to clear these doubts to many students in the past as well, but just let me know if if this is something which is going to give you a lot of insights. If you want to draw, you can draw and type in done. Type in done if you are done, done understanding this and writing this. Neil says clear. Okay. Done, Shrey. So don't be impatient when it comes to core engineering domain. Don't be impatient. You are going to have a lot of vertical growth. You are going to grow in your own organization. After 7-8 years, you can move yourself to program management professional, PMP. You can move yourself to, you can give GMAT and you can move yourself to management side. It's a techno managerial activity. You can move yourself to sales side. You can move yourself, but it is after 7, 8, 9 years, 10 years of experience in a core engineering domain. That way you will have greater bonds, greater connections, better understanding of product. You will have a command of what is happening in supply chain, and then only you will have a big say when you move on to the next career path. Okay, making sense? So how many of you got a feedback from an industry or from an article that mechanical is dying? Don't go for mechanical, core engineering side, there are no jobs. Am I right? This is what you are hearing, right? Switch yourself to Java, switch yourself to coding, and then it happens that people do this and they really don't have anything to say if they don't succeed in that domain, right? So I don't want you to lose hopes. India is going to be the manufacturing hub for the world. Okay, we are right now not able to cater our own people of 1.4 billion population. How it is possible that manufacturing is going to die? If manufacturing is not going to die, design is not going to die. If design is not going to die, CAE is the part of design. It's not going to die. You stick to mechanical, you stick to physics, you stick to core engineering, stick to strength of material, stick to applied mechanics, and you will see a miracle. Now, what is it that is needed in the new world? You must know how AI works. You must know how exactly the automation works. You should be knowing how exactly to code anything. So I'm also learning Python. You can learn Python scripting. You can learn TCL/TK. You can learn how the AI works. If you keep on upgrading yourself by sticking to a very large stone of core engineering domain, your career is supposed to get boosted. It is not going to come down. There is scarcity of good engineers in market right now as well. So I will highly appreciate you guys to stick to core engineering domain. It is little slow. It is going to be slower at the initial stage because company is going to ramp you up. And once you pass this 3 or 4 years threshold, you are supposed to see your own career skyrocketed. Okay. Absolutely. So it is, that's what I said, Lloyd, what I wanted to convey is you should have a coding knowledge. You should know how to save time using automation. You must know how exactly Python works. You must know how scripting works. But that does not mean you are supposed to just do the scripting. You are scripting for what? You are scripting for CAE. Why you are doing CAE? You are doing CAE to reduce number of prototypes. Why you want to reduce number of prototypes? To make sure your product comes faster in the market. Is this making sense? This why question is what is missing in entire ecosystem of mechanical engineer. The TPOs are not asking why question, students are not asking why question, and industry is struggling to get good engineers. Making sense? So there is no need of losing hope. We are right now producing second largest mobile phones. Samsung Engineering, LG Electronics, Sony, then Nokia, then whosoever is there, the entire Chinese market flooded with Oppo or Vivo. All of them use LS Dyna for their drop test. Of every handheld equipment, there is going to be a drop test. If there is a drop test, there is LS Dyna. So there will be a drop test on glass. There will be a drop test on the backside. There will be a corner drop test. And if you can actually see a drop test in real world, it's hardly going to be 100 milliseconds or 200 millisecond sequence. But this is something which is always going to be there. Physics is not going to go anywhere. For any kind of a spacecraft exploration also, there is going to be a huge amount of CAE involved. Okay, there will be CFD, there will be CAE. All these things are supposed to be in a virtual environment tested. Making sense? How many of you feel pumped up by listening that there are enough jobs, but there are not enough takers? Are you feeling a little bit of, I don't want to motivate you. Okay. Motivation is like a drug. It's like just putting some cocaine in your mouth or in your respiration system. It's not cocaine. I'm giving you a fact. I'm giving you a reality that there is going to be manufacturing scope. If there is manufacturing, there is design. If there is design, there is CAE. If there is CAE, you have to focus on both basic engineering. Clear? Makes sense? Okay. So don't ever listen to someone who is not a mechanical engineer and telling you that there is no scope to mechanical engineering. Ask someone who is working in the engineering domain for 15, 20, 30 years and ask them what is there in mechanical engineering side. If you have an electric vehicle, the mass increases. If your mass increases, a regular Nexon, an IC engine Nexon, if it weighs 1200 kilograms, the electric Nexon weighs 2000 kilograms. That 800 kilogram mass difference in battery is going to make a huge difference when it goes for an impact, when it goes for a crash. Because it is half mv square, it's not going to change. Correct? So if it's extremely important that this is something you must understand. Don't lose hope. There are going to be too many job opportunities in CAE as well. Okay. So yes, Mr. Manthena, I highly appreciate that you are going to throw some insights, but please allow me to cover some more topics and then you can explain to audience what exactly you want to say. Okay. Making sense? Fine. So this is what we tried to understand here. So what is, we will cover to what is crash worthiness, what is static dynamic, why LS-DYNA is widely popular. I tried to discuss this with you because it is a explicit dynamic code. That means it is a time code. So I'll first cover the static dynamic and then come to the this particular point why LS-DYNA is popular. What are the applications we already covered? Okay, career perspective. I gave a detailed insight about a career perspective for freshers as well. Okay. Eleno has a good reputation of placing freshers because we convince our customers that freshers are the best product for you. They will stay with you for longer time. They will have a better energy and they will not have an unfocused career path. They will always have a focused career path that this is going to happen. This is going to happen. This is what I'm expecting. And we are able to place freshers in the market because of our pitch. So we are like your sales guys. Okay, so if you join Eleno, we will be your sales guys to place you as a fresher. There is no need of giving some kind of fake certificates, fake letters, fake appointments. It's going to get caught up. No need to lie. If you know that this is something which I have done in last 6 months or 8 months, you will be a ready product for the customer. It will be low cost for them, but more than cost, they want a longer commitment. Okay, and that's why freshers are always going to be a hotcake for sell part. Okay, I'll explain you how Eleno can help you, and there will be an open question answer session. Now let's talk about what is Eleno. Okay, I'll just explain you. ELE is elements and NO is nodes. That's the meaning, and that's how committed we are to FEA, or that's how committed we are to the entire CAE part. So the name itself is formed with elements and nodes. That's why we have this name as Eleno. Okay, and we are focused on training as well as these services. There is a reason I continuously keep myself upgraded because I'm doing the real-time experiments or real-time analysis. So the team is continuously updating me with the new LS-DYNA part, and that is something which I am updating you. And that's why this particular solution business and training business can go hand in hand. So you will always get an upgraded or updated knowledge. Okay, so that is what is Eleno. Eleno is elements and nodes, and we are a focused institute, focused training or coaching institute to make sure you learn LS-DYNA Hypermesh in a clear manner. Okay, so we cleared about current and future market scenarios for CA. It's a huge demand which is going to come up. There are indigenous products which are coming up. The entire defense industry is getting indigenous. There are drones which are going to get dropped. There are missiles which are going to get impacted. There are bullets which are going to get penetrated. There are jackets which are supposed to stop bullets being penetrated. So there is offensive defensive side of the defense domain. And that is something which we are actually visioning for next 5 or 6 years. There will be too many startups in defense or large industries in defense which are going to cater to this kind of a serious business. Okay, let's come to this particular topic, which is what is static and dynamic load case scenario. Okay, so I'll just explain you what is static dynamic. I will also explain you what is explicit implicit. That way you will have a clear idea of what LS-DYNA is actually called as. Okay, what is the definition of explicit dynamic analysis? So next 5 minutes, please listen to me very carefully. If you want, you can take a lot of notes and make sure that you are asking relevant questions at the end of the session. Okay, so you have a very simple thing here, which is called static load and dynamic load. Okay, so we only call it as static and dynamic. That's not the case. We are talking about loads. Okay, we are not talking about just the static scenario and dynamic scenario. So what is dynamic load scenario? If I explain dynamic, you will yourself be able to define static. So if what is a dynamic load? Load which changes its magnitude and or direction with respect to time is going to be called as a dynamic load. I'll read it again. A load which changes its magnitude and or direction with respect to time will be called as a dynamic load. And a similar one will be a load which does not change its magnitude and or direction with respect to time is going to be a static load. Okay, so you have these two important definitions, static load and dynamic load. Now, there is something which needs to be discussed further. All right, so you have understood what is a dynamic load, a load which changes its magnitude and or direction with respect to time. But there is So there are three design. I'll call it as three design. I have created a YouTube video as well. You can visit my YouTube channel, LNO Engineering Learning Center, and you can actually see this. I actually stopped on a highway and on a freeway, and I discussed about three design principles with the real time objects. Okay, so the three design principles are static load, static design. So if this is load, this is design principle. So you have static load, static design principle. You have dynamic load. So the load is dynamic, but the design is still static. And you have dynamic design or dynamic load and dynamic design principle. So I'll just give you a few examples. Static load, static design is you have a table. You don't have too much things going on that, or you have a chair, not too many things going on that, or a shelf. All these things are static load. So stress is equal to force per unit area. Okay, you have dynamic load, static design. That is going to be another important aspect. So what do? You have bridge, for example, or you have civil structure. The loads are dynamic. The vehicles are moving. There will be a bus, there will be a bicycle, there will be a motorbike, there will be another truck. So the loads are changing, the direction is also changing, but you are actually considering it as a static structure and you are applying a dynamic load factor. So what do? You are converting that dynamic load into a static equivalent by just multiplying it by 9.81 and multiplying it by some more factor, which is a dynamic load factor. Is this making sense? Clear, everyone? So dynamic load, but the design is static. Bridges, civil structures, all these come under dynamic load, static design, or light poles, all these come under this. And then you have a dynamic load, dynamic design, which is crash, impact, blast, and drop. Learning something? Type in learning if you are learning something. Okay, so we talked about dynamic load, static load. We are right now talking about three design principles. So there will be static load, static design, dynamic load, static design, and dynamic load, dynamic design. Type in learning if you are learning something. Learning, right? Yes. Okay, Abhishek, yes. Herbert, learning. Yes. Aniket says learning. Perfect. Shreyas is learning. Making sense? So this is the core of the design aspect. You have an object, somebody, let's say your friend comes to you, he's not an engineer, and he asks you to design something. What is it that you are going to consider? You're first of all going to consider whether the load is static or dynamic. I am supposed to design something for a load, right? And then you are supposed to go to the design principle. Even if load is static, even if load is dynamic, what is it that I'm going to imply? Am I going to use the static design principle or am I going to use the dynamic design principle? Okay. Once you have understood this, you have a better understanding of which software to choose. Okay. So we'll come to this explicit dynamic part now. Now you have numerical methods. Let's come to what is implicit and explicit. So you have numerical methods. There are two types of numerical methods. I'm purposefully considering this as session 0. So if somebody joins my class, somebody joins LNO for LS-DYNA training or Hypermesh training, you are going to start from this session onwards. Okay. So there will be session 0, session 1, session 2, session 3 like that. I'll explain you how exactly I teach in last 5 minutes. And then we will have a question answer session. Okay. So we are on time. We will finish at 7 o'clock exact. Okay. Or maybe if extension is needed, those who want to extend or those who want to talk to me more, they can stay. If not, you can meet me later on LinkedIn or on my WhatsApp link as well, or you have my email address as well. Okay, how many of you received my emails? I sent it not in an automated manner. They were personalized emails. It is from Eleno ELC Pune @ gmail.com. You received that, right? So it's my communication address. You can talk to me. You can ask me any questions. You want to meet me in a one-to-one manner in Zoom or Teams format. You can do that in a later part. Not an issue. Okay. So there are two types of numerical methods. One is going to be a direct solving method, and there is going to be an iterative method. Am I right? So in iterative method, you search for one solution. You have bisection method, you have Runge Kutta, you have Newton-Raphson, all these comes under iterative. You do iterate. If you are not coming or your error percentage is not reducing, what you call it as? You call it as diverging. The solution is diverging. If you have something where the error percentage is reducing and it stops reducing to an extent that it is giving you the same number, you call it as a convergence. You call that solution is converging. So you have direct solving method where you are not looking for one solution. You are looking for a progressive solution where you will have different output at each time interval or X value. Okay. So what is happening when we put it in the graph format or graphical format, the direct solving method will have abscissa, that is x-axis. Okay. So you have abscissa and ordinate, and you will have a solution for a particular input, and it is what? Progressive. Okay. It's not one solution. You will have solution at each interval. So solution at each interval, whatever interval you have proposed, and that interval is called as least count. Making sense? And because this particular method, the direct solving method, it can be central difference method, it can be Taylor series. So all are the derivatives of Taylor series where it's an infinite series to solve a problem. So when you have this interval, which is, let's say, at a predefined particular, what you can say, value, that value is going to be called as least count. And you are going to have solution at each least count value in a progressive manner until you terminate the simulation or terminate the cycle. So what is it that progresses and it has no human control? It is time. Correct? You cannot come back in time. So this is a progressive solution, whereas when you come to the iterative solution, it's not always progressive. What do you do in iterative? Let's say you have this as a guess. This is a guess solution. Okay, you have to guess first. That's the predeterminant criteria. And the actual solution is here. What is going to happen? You will have some formula, then you will get a first solution, solution number 1. Then you are going to compare the percentage error. Then you will get a solution number 2. So what is it happening? You are actually moving in abscissa in both directions, which is not possible for time to move on, right? You cannot go back in time. So you are supposed to only move forward in time. That's why this particular iterative method is not suitable for time domain. And what is definition of dynamic load, guys? With respect to time. Correct? So if your load changes with respect to time or is changing with respect to time, you cannot use an iterative method for solving a time problem. So what is the definition of explicit and implicit? It is called as explicit code. Okay. What is an explicit code? Direct solving method. Okay. Direct solving method used to solve a dynamic load problem is called as explicit code. Making sense? Nobody is going to teach you this, I guarantee. Okay, nobody is going to teach you this to this core. So what is explicit code? Direct solving method, that is a numerical method used to solve a dynamic load problem. You are going to call it as explicit code. Then what is the next thing? Implicit code. You just have to replace the words. Okay, what is it? Iterative method used to solve what? A static load problem. You are going to call it as implicit code. Making sense? Now there is one more definition which typically being asked in an interview, which is called as what is quasi-static analysis. Am I right? So what is quasi-static analysis? Quasi-static analysis is not a method. It is a type of analysis which uses explicit code for static problems. Okay, understand this clearly. You're using this explicit code for static problems, then you call it as a quasi-static analysis. So there are problems where there are large deformations. You may have a steel rule, and if you try and keep on applying load, the load is still elastic. That means you are still in elastic limit. The ruler is going to come back. But that steel rule is going to have a huge deformation, which is sometimes not solvable using implicit code. So what do? We use explicit code to solve a static problem. And what is static problem? When you have kinetic energy equal to 0, you call it as a quasi-static analysis. Because what is kinetic energy? Half mv square. V is time component, right? Velocity is time component. So if you have velocity, that is kinetic energy equal to 0, you call it as a quasi-static analysis. Make sense, guys? Everything understood? Type in understood if you have understood this. Runal, you want to ask anything? You can keep your questions ready. Okay, I will be answering all of the questions. I'm not going to run away. I'll answer all of the. Understood? Interesting. Okay, it is still relevant, guys. there are people who are mistreating mechanical engineering. There are people who are not having belief in mechanical engineering. There are people who are not really understanding what is mechanical engineering. And that's why you can hear these jargons that there are no jobs in mechanical, there is no growth. Why will people work on lower salaries after 5 or 6 years of their career, right? That's not never going to happen. Fine. Okay, good. Perfect. So I hope I tried to cover this explicit implicit part in a better manner, okay, for you guys. And if I just go to the list which we were talking about at the initial stage, that we covered what is explicit dynamic analysis, and now we have an answer. Why LS-DYNA is so popular? It has a huge material library. It is extremely flexible. It is not like ANSYS. Okay. This particular explicit dynamic solver has everything which can be controlled by user. So you can control material, you can control database cards, control cards contacts, you can control how exactly the spot welds behave. Everything you can control as a user. That's why it is very hard to teach. Okay, it's easy to learn if your teacher is good, but it's extremely hard to teach in a sequential manner because it has too many variables. It has too many parameters to understand. If you crack a code, if you understand how exactly LS-DYNA works, it's the most beautiful explicit dynamic solver right now available. It's the only solver which is commercially being used everywhere. There is Radios, there is Pamcrash, but the percentage is so low that nobody uses Pamcrash and Radios on a scale at which LS-DYNA is being used. So almost 95-96% of the market for explicit dynamic analysis is LS-DYNA market. Okay. So every global organization uses LS-DYNA, and that's why it is very important for you to learn LS-DYNA. There is good growth in LS-DYNA. There are ample jobs available. There are what you can say, there are switching options available. So you can switch from automotive to defense, from defense to railways. So you can change your domains for initial 3, 4, 5, 10 years, and then you can settle yourself down in one of the product. That is the power of this entire LS-DYNA part. Okay. So this is what I wanted to cover. I covered what is static dynamic, what is explicit dynamic analysis, what is crashworthiness. I will give you a definition, and then I will come to how LNO can help you, and then we will come to question answers. Okay. So the first part here is I'll just share my screen again. And here you go. I think I'm sharing this. Yeah. So we are going to discuss about this part. Okay. So we covered, as I said, we covered what is static dynamic. We covered what is explicit dynamic. We covered why LS-DYNA is popular. We covered what is career perspective, and we are now trying to discuss how LNO can help you. Okay, so we have a very simple plan for you guys. Okay, and then there will be discounts for those who are interested. Okay, so the first plan is, there is a plan that I'll call it as a subscription model. You all are going to get a PDF which explains what is it that we are going to cover. This subscription model is silver membership, silver subscription, gold subscription, and diamond subscription. Silver is only hypermesh and an entire 40 hours class of basics of engineering. So it will cover physics, applied mechanics, strength of materials, design, dynamics of machinery, theory of machines, manufacturing processes, metallurgy, and numerical methods. 9 different topics which are according to CAE interview. So it's kind of an interview preparation. This is a silver membership. You have a gold membership, which is going to be silver plus LS-DYNA. Okay. And there is an important aspect here, which is placement assistance. Okay. And when I say placement assistance, it is till you get placed. There are no caps, no questions, no reasoning. You are supposed to be with me. I will be your mentor. I will handhold you. I will make sure you are getting placed. Until you are getting placed, there can be failures. It's perfectly fine. We are all humans. So there can be 1 or 2 failures, and on third time you are going to get placed. That's my responsibility. Okay, so we are going to have an assistance. It's not assurance. Assurance is a fraud. I'm not assuring anything because there can be many factors which may go wrong. But we are in a human manner, we are going to correct ourselves and make sure we are job ready. Making sense? So it's going to be placement assistance. And what is diamond? Diamond is entire gold, including placement assistance, plus there is going to be an entire product domain. So we are going to talk about product. So in this LS Dyna, what we are going to cover is we are going to cover 10 different problems of different varieties. Okay, so it is all explained in PDF that I'll discuss later. So this LS Dyna consists of 10 projects. First 4 projects are single part projects. So there will be no assembly, nothing. It's single part. First, maybe 4 projects. It is to give you idea how LS Dyna works. The next 6 projects are going to be extremely, what you can say, challenging. They will be industrial projects. There will be seating system project. There will be defense related blast or impact project. There will be a project related to drop test. Okay, and then there will be a project related to your choice. Maybe somebody has MTech session to be, or MTech project to be solved, or a PhD project to be solved. We can have that project in gold. Okay, so in LS Dyna, it's generic. We will make you job ready. We will make you independent in LS Dyna, but it's not specific to a domain. But what we do in Diamond is something which is very specific to a domain. So it can be seating system, it can be full vehicle, it can be interior system, it can be defense, it can be railways, it can be seat which is related to aircrafts. So you are supposed to choose a domain after you finish your gold, and then you can upgrade to diamond. Or if somebody is already working in seating system and they want to only do career in seating system, you will have this diamond membership going on. All right. So the engagement changes. So you can anytime upgrade from silver to gold, gold to diamond, and you will get an upgraded package. I'll just list down what is the cost for this. In US dollar figures, I'll share it with everyone anyway. You will get a brochure. But for silver, it is 2 months program. And it is going to be, we are expecting 1 hour per day as your engagement for Hypermesh, and it is 13,999. You have gold, which is a 4-month program. Again, we are expecting 1 hour per day engagement. Okay. And it is going to be 56,999. This is in Indian rupees. And we have diamond program or diamond membership, which is going to be a 6 months to 7 months program. We are expecting 1.5 hours per day. We are expecting higher engagement, and it is going to be 88,999. Okay. Now, how exactly this works? All sessions are self-paced. That means if you are able to invest more time, you will finish your course faster. How? You will have self-paced sessions. Okay. All sessions will be given access to. Myself, Nachiket Phadke, personally, I'm going to meet you on every Wednesday, Saturday, and Sunday in the evening time, maybe 8 p.m. IST. Okay, right now also I'm meeting almost 30 odd people on Wednesday, Saturday, and Sunday live. Okay, so this is going to be live. We will share our screens. We will talk about your problem. I will debug your model. I will answer your questions. And it's going to be what? It's going to be a community learning. Why? Because somebody who has a question, you may not have that same question, but you get a new question, new perspective, and you get an answer as well. Interesting, right? Solid. So this is working like a miracle. We are able to generate a lot of employment because of community learning only. And this is something which is super useful for everyone, including myself, because I can understand a spectrum or variety of problem statements from you guys. So you are not just getting 1 or 2 softwares to learn for. Okay, what you are going to get when we talk about this diamond membership, you are getting Hypermesh access, you are getting LS Dyna access, You are going to learn LS Prepost, which is a pre and post processor for LS-DYNA. You will be learning Hyper-V. Okay. You will be learning seating system or interior system or full vehicle based on your choice. You are also going to learn PowerPoint presentation, how exactly generate the PPT. I'll call it as PPT. Okay. You will be learning Excel for formula, various formula creation. You will be learning soft skills. Okay. You will have soft skill training as well. My camera will restart. Okay. It typically stops after some time. It gets heated. But just bear with me. So you'll have Hypermesh, LS-DYNA, LS Prepost, Hyper-V, and placement assistance. Last but not the least. Okay. And you can start it from any time. So if you are ready today, you can start it from today. If you are ready from tomorrow, you can start from tomorrow. And the admission process is very simple. Get connected with me on LinkedIn or on my email address, which I shared with you. Make sure you're talking to me. Make sure you have a Zoom call if you want it. There are people who have already come down, walked in. Neil was there. There is Prasad. There is Abhishek, Abhijit. All these guys came. I asked them to attend this session first and then decide whether to join or not. So they walked in. They understood the process and they are in process of finalizing one of the course. Okay. So the most value added course for you guys is this most value added because it is at a middle cost, but it is giving you the maximum which is needed for a fresher. Later you can upgrade to diamond if there is some kind of a lacuna and you can just pay the difference and upgrade yourself. So this is something which I have chalked out. It's working in a fantastic manner. There are people who are getting benefited. There are anonymous people who give me feedback on LinkedIn or Facebook. There are people who don't want their names to be disclosed. There are people who are meeting me and giving me feedback that this is something which helped us boost our career. And this is my 10th year. So I'm pretty happy that I was able to help almost 800 plus engineers in LS-DYNA in my last 8 years. Okay, so it's not a big number, but it's a very specific domain. It's a core domain. And in all the turmoils, I was still able to place people, freshers. Okay, not the experienced guys. I trained people from UK. I trained people from Mexico, USA, all parts of the entire world, wherever I can reach, wherever there is internet. I'm still training people. And that's all from my side. I just wanted to cover all these topics. Now we will come to the question answer session. And what I'll do, I'll just stop sharing and I will allow. Second, I'll just allow. Let me change the meeting settings and I will allow anyone to talk. Allow mic for attendees. Yeah, there you go. Save the setting. So anyone who has a question, you can raise your hand. Kunal, I think your hand is raised. You can unmute yourself and talk.
Yeah, hello. Good evening.
Yes, yes, very good evening, Kunal.
Yeah, actually, since last 10 years, I am users of ANSYS,
Okay.
specifically on the thermal management side.
Okay.
And currently, I am actually explore the electromagnetic side, means where I am doing that PCB simulation.
All right.
For the thermal analysis. So where we have one of the requirement like a drop test simulation for that LS-DYNA.
All right. Okay.
So I just want to know, means there is in the ANSYS there is another explicit solver is also there, dynamic.
Autodyne is there.
Yeah, Autodyne is also there, and another ANSYS solver is also there for the dynamic impact analysis.
Yes.
So yeah, so how that means help me LS-DYNA? Suppose.
Of course, it will help you. Only thing is the licensing part apart. It's an entirely different kind of a learning when it comes to LS-DYNA training because it's not like a basic static analysis or pick and place kind of an analysis. It has involvement of materials. You can convert your ANSYS file to LS-DYNA file. So we can help you out. So what I can suggest here is, if you are not in the need of a preprocessor, let's say you already know a preprocessor, you can only have this gold membership without Hypermesh. So we can reduce that cost as well. You may be knowing Hypermesh, you will only come to LS-DYNA training, and I will help you with your own project, and you can keep on applying it for the entirety of your career in the next time with your own understanding. So that's what hand holding will be.
Okay. And could you explain me, means what is the future of this, like particularly in for that power electronics side, where we can apply this?
It is actually extremely well placed. The only issue is we are till this date, we are not designing our own products. As Indians, we are just copy and pasting it, or making just some small tweaks and moving that products in power electronics. But it's very vast. It's coming up very fast. There are defense equipments, there are general equipments, there are power equipments. So I think it's a good way of exploring. I'm not a domain expert in the electronics or electrical part, but based on the inquiries which I get, I can still sense that there is a huge demand, there is requirement for solutions. I think you can safely bet on this. It's not a huge investment for you, and it's not going to go anywhere. The knowledge will be still with you.
Okay, thank you.
Yeah. Thanks, Krunal, for question. Yeah, Neil, go ahead.
Yes, sir. Good evening, sir.
Yes, very good
sir,
evening.
my question was regarding the lectures, so the training sessions. So,
Okay.
what kind of training sessions will be conducted? Will it be live, interactive?
Yeah, that's what I said. It's a self-paced learning. So when I call it self-paced, they are pre-recorded. So they are my sessions. They will be pre-recorded. You can watch them anytime, any number of time, anywhere. It's on my learning management system called Teachable and Easy course. So you will have the access. It's lifetime access for you. There is no access restriction. And if you have questions about a particular session, so for example, you learn very fast. There are people who finished the entire LS-DYNA in 2 months because it was their industrial project. So they wanted to learn LS-DYNA faster. So they finished faster. They asked me a lot of questions in all the question answer sessions. And you can simply go forward and have the session repeated if you are appearing for an interview. That also is possible. And then you can have an interaction with me. So it's a self-paced, pre-recorded learning. It's not a live class for sure.
Okay. Okay. Thank you, sir.
Thanks, Neil. Yeah. Okay, Vinayak, do you have any question? I think you are on unmute. I'm not sure. Neil, can I lower your hand? Yeah. Okay. So there is Vikram. Yeah. Manthena, Mr. Manthena. Yes. We'll take your part last because I think you have some insights to share, right? So anyone, if you have any questions, just let me know. Yep. Guest. No, I'm not sure who raised hand. No, it's Mr. Manthena only. Okay, guys, have you found this session useful? Have you learned something? I think somebody's having any festival discount. Shreya, you can talk to me. I will provide you the discount. If you are willing to join, I will give you discount. Don't worry. Aniket, Nastran is also a good tool. If somebody is there to teach you Nastran, Aniket, you can simply go forward and learn Nastran. But you need a mentor, guys. Without a mentor, if you try and learn anything, it's going to be extremely difficult for you to make a progress. Useful, right? Okay, good. So, Mr. Manthena, you can go. You can go forward. What are your views? You can unmute and talk.
Hello.
Yes. Yes, Mr. Manthena.
Am I audible?
Yeah, audible to everyone.
Yeah, hello. I have few doubts, and I would like to know how deeper insights we can get over this course, like in crash worthiness, especially. connections, integrity, vehicle integration. I meant, yeah. And how deep will those things be discussed?
See, the trouble with vehicle integration is every
Yeah.
single organization has a different approach to vehicle integration.
Yes, yes, yes.
Okay, so I can teach you a generic connection parameters which I learned over the years. So
Yeah.
it's always going to be there with you. So there can be spot welds, there can be seam welds, there can be 2D, 3D welds. All these things will be there. So there is
Yes.
going to be something which is a generic part, and then there can be something which is a specific part for a specific organization. But that's going to
Fine.
be their own, what I can say, trademark or a continuous improvement program.
Yeah, yeah.
Making sense. So we will be teaching you through for an every single. So there will be trainings for joints. There will be trainings for various types of connections, which are bolting, preloading, preload of a bolt. Then there will be 3D bolts. So everything we will cover in LS Dyna. We are not going to leave us with any stone unturned. We will make sure that everything which is possible in LS Dyna for explicit analysis, we will be teaching you.
Okay, fine.
But
and one more thing.
I don't know
Is there?
what is happening. What is happening in Fiat Chrysler? What is happening in Tata Motors? What is happening in, because that's kind of a
Yeah, of
specific.
course, of course. Yes, yes. I got that what you meant. And one more doubt is, how far will be discussing this durability kind of
No,
problems?
there is no durability covered in LS Dyna. Durability is typically a good ball game for Abacus. Okay,
Yeah, of
so
course. Yeah,
okay,
yeah,
so durability, we are not going to cover anything about durability in LS Dyna. That's not cup of tea. LS Dyna's cup of tea.
yeah. Fine. I mean, when I meant durability, I meant is that at least discussed in engineering basics?
Yeah, it is discussed in engineering basics for sure. Durability will be discussed in engineering basic. Fatigue is discussed in engineering basic because the material science revolves
Yeah,
around that. So we will
yeah,
be
yeah.
discussing it, but as far as the software is concerned or expertise is concerned, I'm not an expert in durability, to be very frank. So I cannot give you a durability perspective as far as the product is concerned. We may have some lecture or some session from durability guest, and somebody can
Okay.
explain you what is durability, but that's the only thing which I can do.
But engineering basics are covered, right? That's
Yes,
enough. Yeah,
100%
I
we will
can.
cover.
Yeah, yeah. That's what
And
I was
even
expecting.
what I'm doing, I will tell you, I'm
Yeah.
actually asking questions to my student, what is it that is needed in engineering basic that you want me to cover,
Okay, okay. That's
and
very
I
good.
study
It's
and I
very
add
good.
that session.
Yeah,
So you will always get an access to the newer sessions whenever they are online.
yeah, yeah. Got it. That's very good to hear, Nishket.
Yeah.
And Diana, once we are done with this course, uh, are we covering the entire length and breadth of this LS Dyna?
Actually
Like
related to
debugging, for
yeah,
example, the errors
that's
are
the
common irrespective
yeah,
of the problem we solve.
absolute. So debugging is a very important part. How to identify an error is an important part. We will
Yes.
make sure you understand what is the error, how exactly to handle this kind of an error, and why this error should not occur in your next model build up.
Okay, fine.
So
And
anywhere you, if you can go to one of some of my connections, maybe, or a mutual connection, or uh, uh, I'm actually one of the key member who discovered some of the methodologies to find out errors in an ingenious way in my organization,
wow.
which was Tata Johnson Controls. So
So,
errors is something which I love, and why
oh,
they come and how to solve them is something which I master in. So I will be personally guaranteeing you that I'll be making sure that your errors are getting solved.
yeah, that's very great, Nishket. That's what I was expecting. And as I discussed earlier, I don't know whether you remember it or not. I don't want to take Hypermesh because that is the tool I was using since last 4 to 5 years. And
Perfect.
is there any other tool we are going to discuss or no other tools?
It will be LS Prepost and it will be Hyperview. LS Prepost is something which I teach
Yeah, yeah, yeah.
everyone because it's a
Yeah,
free tool and it
free
gives
tool.
you a
Yeah,
lot of command over
yes,
model. So for model checking, it is extremely good.
yes.
and that's why we teach LS Prepost. So you'll be learning LS Prepost with me.
No, I was asking like, alternate to Hypermesh, like ANSYS or ANSYS.
No, ANSYS we don't have a license. ANSYS we don't have a. So we have a commercial license of LS Dyna. So we can teach you LS Dyna. LS Prepost is anyway available. But ANSYS we don't have a commercial license, so we cannot teach you.
Okay. So can I expect any discount regarding that? Because
Yes.
I don't
So
want to take on HM.
you reply, yeah. So discount is like, it's very simple. You have gold membership minus the silver, whatever is the value, it comes to 42,999. You're simply going to learn. So I'm not bluffing anyone. Okay. So I just want to make it straightforward. So if you are not learning something from me, you are going to get that part shed away. As simple. Okay. So the cost will be 43,000 for you, 42,999. And that's a pretty hefty discount because you are not learning Hypermesh.
Yes. I was expecting to take, I would like to take Diamond.
I know. So for you, the Diamond will be you can have an upgrade, but again, it will be a simple upgrade where you will have a domain expertise, but we can discuss in a one-to-one manner when you want to upgrade to Diamond. Okay.
Okay. Fine. Yeah, that's all from my side. Thank you.
Okay, good. Thanks, Mr. Manthena. Yeah. Okay, any other questions, guys? I hope you have a good, Mr. Prakash, you can go ahead. You can unmute and talk.
Hello, sir.
Yes, Prakash. Yes, go ahead.
Hello, good evening.
Yes, very good evening.
I would like to know about the specification which is required for this computer.
Oh, wow. That's a very good question. See, I'll tell you, LS Dyna is free of cost to everyone. It runs on, so you get a 4 CPU license. That is 4 core license for LS Dyna to run as a student version on your own computer without registration, without anything. It's not a crack version. It is from ANSYS website. The specifications listed, or they are supposed to be like i5 or i7 computer. You should have a graphic card of at least 2 GB, or 6 is always good, 8 is always good, but 2 is more than sufficient for LS Dyna to run. Graphic we really don't need. Only for model or simulation we need that, or the animation we need that. And a RAM should be minimum 8 GB right now, and you should be able to upgrade it to 16. Okay, so that's the only specification for a laptop. Okay, I think my typical suggestion to all my students is, if you are planning to buy a laptop, go for a second-hand workstation, which is either a Lenovo ThinkPad or an HP ZBook or anything which is related to Dell Precision series. So they are super durable. They don't die. They are like built like a tank. And they are always used by somebody who is working in an organization. They are never used by a consumer. They are not consumer laptops. Okay.
Okay, sir. Thank you. And I have one more question.
Yeah, sure. Go ahead.
Sir, nowadays most of the tools there will be an AI assistant. What will the future of this LS Dyna?
The AI. What happens? I'll tell you. The AI is dependent on the data points, previous data points. Am I right? It's not something. It's generative, right? So it's not something which can give you an answer right now. Okay, I'm not talking about farther future, but right now it is all dependent on previous data. So there are good AI tools which are going to give you some insights about what is going to happen to this geometry. But that if you change one of the parameter, the AI may not be able to give you a correct suggestion. Again, it's going to go back to the data points, and it will not have enough data points to give you a predictive answer. So my overall suggestion is, the AI will be useful for your initial part, pre-processing, or this particular initial part. The solving is anyway automated. You really don't have to worry about what happens inside the solver. Okay, so the AI will be useful for, on automation will be useful on a pre-processing side and a post-processing side. The solver will remain the same. The model setup is still going to be manual. And that's why I'm not too much worried about it, because anyway, if it is physics, it's all going to stay as it is. Okay.
Okay, sir. Thank you. Thank you.
Good. Any other questions, guys? Anything about so guys, I will be very open to you. We are having a commercial. We are the only institute with commercial LS-DYNA license for teaching. So you will have an unlimited access. And at the same time, you will be talking to me on a weekly thrice manner or a daily manner. The WhatsApp group is super active. So you can always have a WhatsApp discussion with me. You can always have a chat with me on our group. And in that manner, it's going to be a super supportive environment where there will be continuous source of information. I will never motivate you. Remember, the motivation is going to be a short stint of boost, which you are going to get. It's not going to take you long. What is extremely important is why we are doing this is something which you are supposed to hardwire in your brain with me. Because I'm in this field for 18 years, I can confidently tell you that this is the field which will be stable for another 18, 20, 25 years. Okay. Look, Lakshman, to be very frank, this is my service. Okay. So there is no price for my placement assistance. It is my own friends who are helping me, my connections who are helping me. We are not charging students for any kind of a placement. Okay, so the placement assistance is something which is a service to my own community, mechanical engineering community. So the prices are not going to change even if you don't need a placement assistance, because the price is for content, not for placement assistance. Okay, that's why I want to explain. Okay, so there are no price changes if you don't want to avail the placement assistance part. The price will be same. Okay. Good. I think we are 23 minutes ahead of time. I'm extremely thankful, guys. Thanks a lot. And this is something which is very, very much I was looking forward to it, because I never had a session in last 2 months. That's not good, but I was busy with the travel, and I was going to Delhi. I was traveling a lot, and that's why I was not able to find time, but I made sure that I'm going to find time for more sessions like this. So thanks for attending. Thanks for coming down, finding your time for 2 long hours. And it's been a pleasure to discuss with you guys. Even if we don't join hands at LNO, we'll be still around getting connected. You can ask me any questions. I'm always there to help you. Okay. Thanks a lot. I think there is one last, I think I got a ping for a chat. 1 second. Is there any installment? Yes, Aniket, installments are available. We get 2 installment options. So you can pay your fees in 2 installments. So if it is a diamond membership, it will be 2 installments. If it is gold membership, it will be still 2 installments. For silver, we don't have an installment option. But if you want to pay using credit card and convert it into EMI, we'll give you a link. And once you get a link, you can pay using your own credit card and convert that into an installment for 6 months, 9 months, 12 months. That way you can spread your entire expenses over a period of 1 year. That's possible. Thanks, Yash. Thanks for kind words. Yes, it is supposed to be eye-opening, because I can see a lot of rumors going around that there is no scope in mechanical, why you are going there, etc., etc. I just wanted to clear those doubts. Okay, see you guys. Thanks a lot. Have a great night ahead. Thanks to those who attended from so long of a session. I'll send this recording if something you missed around. I'll convert this and send it to you. Thanks, Neil. Thanks, Aniket. You're most welcome, Tejas. You're most welcome, Shreya. And hope to see you at LNO as fast as possible. I really want to help you out. It should not be a transactional affair. It should be a human to human interaction. It should be a close community, and I want to make sure everyone succeeds in core engineering domain. Okay. See you guys. Bye.